Hi everybody. Today we're going to go over basically some introduction to logarithms, tie this to the graphs. This took 2 days in class to do, so this is kind of a long video. We're going to start by taking a look at the graph. Since we did just do graphs, we're going to graph these two. You can put them in the calculator, and let's just take a look at the picture itself. So if we think about y equals 10 to the x, you don't have to make a table, but if we make it 0, 10 to the 0 power is 1. If we make it 1, 10 to the first power is 10. So we have these 2 points on the graph. Now I'm not going to draw the asymptotes because the asymptotes interfere with each other. Ooh, that's a little wiggly. So just to kind of keep the graph a little cleaner, I'm going to not put the asymptotes on there. Now from the logarithm graph, we know that the asymptote is the y-axis, so we go 1 point to the right, and we also know that we do base comma 1, so that would be 10, 1. Because when there's no base, it's base 10. So here's our 2 graphs, one for the exponential with base 10, one for the log with base 10. And the question over here says, we have inverses, we know they're inverses. How does the graph support that statement? This red line is the line y equals x. And inverses reflect over that line. And you can see that these 2 graphs do that. So that's how the graph supports the fact that they are inverses. Now, knowing that they're inverses kind of helps a lot. To show you what that means, take a look at part C. We have a point 2, 100 on the graph of y equals 10 because 10 squared equals 100. So we know that 10 squared equals 100 is true. Explain how you can use this point and the properties of inverse functions to determine the value of the log of 100. Well, if 100 is on the graph, then 102 would be on the log graph. So if we plug these numbers in, so the log of x, so the log of 100 would equal y, and y is 2. So that's how we can do that. Also, if we think about log the base 10 of 100 equals 2, what does this really mean? So we start here, the power lives way over here, and the answer is inside. So this is basically 10 squared equals 100, which is what this is telling you. Whoa, sorry, that got a little crazy. So that's what that's telling you right there. Logarithms are just simply to get the power down out of the exponent. That's all we use logarithms for. So we want to focus on that. We want the power to be what's isolated because that's where the variable will be. So just because a lot of times rewriting something, they're not really solving anything, we're just moving stuff around. So just to practice that, we're going to start by doing some of these. So we start with the base, you come way out here to the power, and then you go back into the answer. When you write this, it should be factual. It should be a true statement. So 3 to the 4th equals 81. By that I mean we didn't write 81 to the 4th equals 3. So it should make some sense. For number 2, we would have 25 to the 1/2 power equals 5. Now what this is saying is the 1/2 power, that's the same thing as the square root. So the square root of 25 does in fact equal 5. We're going to try some without the calculator, then I'll show you how to use the calculator. This has got to swoop this out. We got to basically undo this logarithm. So 3 to the what power is equal to 27. The trick to this is we want to make the bases match. If we can get the bases to match, then we ignore the bases and the powers become the equation. So 3 to the x, we can't change 3. 3 is a 3, but 27 is 3 to the 3rd. And now that the bases match, we can ignore them and just use the exponents as our equation. So x equals 3. 4 to the x equals 2. Now you can't change 2. 2 is to the first power. So it doesn't matter which side you change. Sometimes you have to change both sides. 4 is really 2 squared, but there's still an x there. So again, we ignore the bases. This comes down. 2x equals 1. So we get x equals 1/2. For number 5, we swoop this out. We have 10 to the x power equals 1 over 100. Well, again, we can't do anything with 10. but 100 is 10 squared. Now, in order to get this down out from the bottom of the fraction, we have to make it a negative exponent. Negative exponents are reciprocals, and they flip from the bottom to the top, or from the top to the bottom. And so now we have 10 to the x equals 10 to the negative 2, so we ignore that. So we know that x equals negative 2. So that's great if you can actually get the bases to match. When we can't get the bases to match, you're going to have to come up with some other way to put it in the calculator. If you go to the math key on your calculator, look for something that says log base, like this. It'll show up log, there'll be like a square and a square out here, and you can make anything match what this says. If you don't have that key on your calculator, then you're going to have to use this formula. And the formula basically just says, hey, put the base on the bottom. So this is the log of 8 divided by the log of 5. When you type this in the calculator automatically does this for you. You're going to have to hit close on the parentheses and then divided by. So make sure that you close the parentheses on the top or you get the wrong answer. We always go to 3 decimal places. So pause this video and make sure you can type it into the calculator correctly. This wanted a base 10, so that's the common log. You can do the same thing with the natural log. It doesn't really matter which logarithm button you select as long as you make them the same top and bottom. So this would be the natural log of 12, and again, you'd have to close those parentheses divided by the natural log of 2. Go into 3 decimal places, we get 3.585. Now the way we're going to use this, kind of everything from the front, is right here. We have somebody studying a colony of bacteria, doubling time of 1 hour. Write an equation, an exponential function to determine the bacteria after t hours. So this is the same thing as exponential growth and decay. Now, instead of having 1 plus r, we have doubling. So our original amount is 20. Doubling means our base is 2, but our time is still there. So if they say triple or twice or half-life, that's your base. Now the question says we want to figure out how many hours before the population is 10,000. So we'll put the 10,000 right here. And I left these steps over here just to sort of help you think through the problem, since this is really the first one you've done in a long time. We're basically going to divide both sides by 20 because we're trying to get that power by itself. So we get 500 equals 2 to the t. Now you cannot divide by 2 because you're not multiplying by 2. The way you undo an exponent is to write it as a logarithm. I just showed you how to put it in the calculator. This is what we want. We want to put it in the calculator. So we're going to write this as a log function. Log, the base is 2, the answer is 500, and the power is a t. So you can see that's why we do it, to isolate the power. So plug this into your calculator, some method from the front, and we get t equals 8 point, we'll call this 966. Logarithms are exponents. That's really all they are. So they follow the same properties. So basically, when you're multiplying, this side is multiplying, this shows you that you add. When you divide, it shows you that you subtract. Power to a power is multiply. Equality is basically what we did on the front. This is where your bases match. Bases match. And as long as they match, then the stuff is equal, is all that's saying. I'm going to go through and show you each one of these properties. So it says we're going to use the properties to expand each. So basically, we're going to take this nice compact problem, and we're going to turn it into kind of a long mess. First of all, each separate term gets the word log. Keep the logs the same. So we're going to use only this log in this problem. We're not going to use natural log or log base anything else. So we have the log of 5. We're multiplying, so that's going to turn into adding. Log of x, and we're still multiplying log of y to the third. Now a power, only the y has a power, so this power has to come down out in front and show that it's being multiplied. So all the rest of these will stay the same, log of 5 plus log of x plus 3 log y. And that's it. That's how you expand it. Now this one has the natural log. It doesn't matter what they tell you, you keep it. So we have the natural log of x. We're multiplying, natural log of y. Now we're dividing. So we're going to subtract natural log of z to the 4th. And once again, we have a power that only goes with this little piece right here. So everything else stays the way it is. So we're going to have 4 natural log of z. Oop, that's a minus. I don't know why I switched it to a plus. It does not switch. It stays a minus. Basically, anything in the bottom should have a negative power or a negative sign in front of it. Same thing, negative power, negative sign. So for this one, let's see, we have the natural log of x, and we're dividing by all of this stuff. Natural log of the square root of x squared plus 1. There's a lot here. Let's just go through it. Square root is fractional exponent. So natural log of x minus the natural log, I'm just going to rewrite this, x squared plus 1 to the 1/2 power. We don't have any way of changing this. We don't change adding. We only change multiply, dividing, powers. That's it. There's only 3 things we can change. So that x squared plus 1 is going to stay there. This power, however, can come in front. So the natural log of x minus 1/2 times the natural log of x squared plus 1. Keep that in parentheses, showing that it's grouped together. That's as far as that one goes. Try to resist trying to go crazy far. Here we have the base 2. So now you just keep base 2 on all of it. Again, I'm going to go through this carefully. We have, can't see it. We have the log base 2, and I'm going to rewrite this, 2x times x squared plus 2. We can't do anything with the plus. This whole thing is to the 1/2 power. This 1/2 power comes out in front of all of this. So now we have 1/2 log base 2 of 2x times x squared plus 2. Now we have a multiplication problem. We're multiplying, so we can separate this. This 1/2 stays here. Log base 2 of 2x. Right, so this 1/2 is actually times all of it, right? Everything, sorry, it probably looks like this. The 1/2 really is over everything. So now we're going to put the 1/2 in front of this. Log base 2 goes with that as well. X squared plus 2. This is another multiplying problem. 1/2 log base 2 of 2 plus, because we're multiplying, 1/2 log base 2 of x plus 1/2 log base 2 of x squared plus 2. Now here we got a trick. Log base 2 of 2. Basically they're saying 2 to the what power is equal to 2. Be careful when all you have are numbers like this one. You can actually simplify this. This is actually a 1, right? Because 2 to the first is 2. So this turns into a 1. So the answer is really just 1/2, because we're multiplying that by 1. That's from right here. Plus 1/2 log base 2 of x plus 1/2 log base 2 of x squared plus 2. Sorry, I was trying to squeeze that in there. Now we're going to go the other way. And we're going to take and we're going to put this back together. It says use the properties to write as in each step. So let's just show, I'm going to show you what the properties do. First thing you have to do is think backwards, right? So we have to take this power and put the power back on top of there. So we're going to have the log, natural log of x minus 1 to the third minus the natural log of x. This is the power property. Meaning if we're multiplying, it's really a power. Now we have to deal with this. Natural log of x minus 1 to the third on top of the natural log of x. This is the quotient property. If we're dividing or if we're subtracting, it turns into, subtracting turns into dividing. Now essentially, we don't need the natural log. We only want to write the natural log one time. So we should have the natural log of this fraction, x minus 1 to the third over x. We don't really have a property for this. This is just simplify or write as a single logarithm. Let's do this one more time. Take care of all multiplying first. I only see one thing right here, the 4. What else do we have? Oh, maybe we should do what's inside first, sorry. Adding. So we have the log of x minus 4 times all of this. The log, let's rewrite this as 1 log. X minus 2, because we're adding, it turns into multiplying, x plus 2. I use the brackets because of the parentheses. Now we can actually do this. This doesn't have anything to do with logarithms. It's just algebra. The log of x minus 4 times the log of x squared minus 4. Now we can put the power back on there now that we have a single term. So that power is going to go here. So we have the log of x minus the log of x squared minus 4. This whole thing is to the 4th power. Now a negative sign means division. So we're going to write this with a single log. I'm just going to skip that step that I did up there. So we're going to know we're dividing. And the power is only on the bottom. We write it with a single logarithm. The assignment is the separate paper. And so go through that. Keep track of any questions and bring those back to class.